I will be talking about Amazon outage that occurred in December 2021. To begin, let me briefly explain what AWS is. AWS offers virtual clouding infrastructure, providing customers with computing resources, storage, and networking. It ensures high availability with data centers in multiple regions and redundancy to prevent service interruption. Key services include EC2, S3, Lambda, and API Gateway. According to official AWS documentation, there are 4 key metrics: MTTD, MTTR, MTBF, and SLA. MTTD and MTTR are minimized to quickly detect and reduce downtime. MTBF is maximized to increase reliability, and through the service level agreement, AWS promises 99.9% reliability, offering credits if this is not met. During the AWS outage on December 7, 2021, an automated capacity increase overloaded the internal network, causing delays and errors. Since AWS services use APIs to link smaller services, the API issues created a domino effect, leading to more performance problems. This triggered even more connection attempts, which made the network congestion worse. Here's a look at AWS internal network, which handles communication between AWS resources. There are 2 EC2 redundancy using Route 53 API. Connections like EC2 to EC2 and EC2 to API Gateway all happen within this internal network. On the bottom left, you will see services like CloudWatch Alarm and Certificate Manager, which run entirely within the internal network. They support EC2 by providing monitoring and certificates to services like EC2 and API Gateway. Here's a quick rundown of AWS outage process. First, internal network issue and traffic congestion. At 7:30 a.m., AWS automated capacity scaling caused a flood of connection requests in the internal network, overwhelming the network devices. This led to communication delays, API failures, and performance issues, which got worse as more retries piled up. As you can see in the image, a lot of API failures were detected. Second, monitoring issues and DNS error resolution. The network congestion affected AWS's real-time monitoring, making it tough for the operation team to diagnose the problem. They found internal DNS errors as a major cause, and by 9:30, they rerouted DNS traffic, which fixed part of the issue. But congestion was still a problem. Without real-time monitoring, they had to rely on logs to troubleshoot. In the bottom image, you can see availability still sitting at around 60%. Interestingly, not all users experience the same impact. Even at the worst point, EC2 in the US East 1 region maintained a 61 success rate, and many users were still able to access the service as usual. Third, congestion relief and service recovery. The operations team worked on reducing congestion by isolating traffic sources and increasing network capacity. Although progress was slow, by 1:30, they made significant improvements, and by around 2:20, all network devices were fully restored. The entire AWS outage lasted about 7 hours, from 7:30 to full recovery at 2:20. In summary, AWS had a tough day, but it took several hours to fully recover while maintaining some service availability. To conclude, during the AWS outage, major services like Amazon Prime, Disney, and even Amazon's logistics and delivery systems, as well as smart home devices and tasks like flight bookings, experienced significant disruption. Despite AWS's redundancy systems, internal network congestion led to unexpected issues, showing that even robust systems aren't immune to failures. Moving forward, it's clear that AWS must focus on preparing backup monitoring solutions that can seamlessly switch to external systems during outage. This will help prevent delays in recovery times caused by monitoring failures, ensuring smoother and quicker resolution in the future. Here are my resources, mostly pulled from AWS homepage and a few articles. Thank you for listening.